Hey everyone, I'm Christoph Rose. I'm the Product Manager Cloud and Software here at TURCK, and I'm excited to present to you this video series about doing sensor to cloud to alarming using TAS Desktop, TAS Edge, and TAS Cloud. Don't be alarmed by the number of videos or the total length. If you want to actually see how quickly it can be done, we have a video for that taking less than 5 minutes. This series is really going in depth, walking you through step by step exactly what you need to do, how it works, all the options you have. So have fun, and I'm looking forward to hearing from you guys. Okay, we've started TAS Desktop, and the first thing we do is check at the bottom that we have version 2.0 installed, as that includes the IoT Edge demo, which we are using here. This is the equivalent for TAS Edge, which runs on a TX or on a Linux server. So the first thing is we scan our network and see all the devices. And for TAS Edge or the IoT Edge demo, we can use the IO Link master. Everything that we want to do, we can access here in the IoT Edge demo. So again, scan the network in here. So we actually only have the IO Link masters. We can see both the master and the sensor and can access the IO Link page of the sensor directly via the button. If needed, you can log in at the top right. I've already done this previously, so I don't need to do it again. TAS Desktop interprets the whole thing, and now we see we have the proper interpretation and can see the live data. Here we can see the sensor value coming in through the teach monitor for the capacitive sensor. And we can see the sensor data coming in. Right now we have some metal going through it. The process value goes down to about 880. For the oil, it goes down only a little bit, and water goes down a lot more. The capacitive sensor is very sensitive to the distance. That's why you need to be sure to have it really in a good position. Let's do it a couple of times just to have some more data to see where is it stable, where isn't it. For our use case here, for the demo, this is good enough because we only want to detect if we actually find something. In real life, the sensor value for the water looks a bit suspicious. Probably there's a little bit of air at the top. Then we can zoom out, look back at the values, and again, for us here, the important part is no matter which material went through, we can see that the value always goes beneath 1600, which we use as our switch point. Here we can see the process data, which was already available previously, but now we have the button at the top to add this menu to the DP template. So by clicking this button, we add all the data available here to be transferred or to be available for transfer to via IoT Edge. However, we can do this not only for the cyclical data, so in the process data, but also for the non-cyclical data. So in this case, we have the observation menu. We have some parameters in here that could be interesting for us. For example, the operating hours or the device temperature. So we can also add it to the template. We can do the same thing with the diagnostics. And with the next version coming out, we can even do it for the values in the parameter. Then we go to the top, we can save the template, we can give it a name and a description so that we can find it later in our template menu. And in addition, what we are doing here is we are applying or writing an application-specific tag. We can use this later for the naming of the data points for data transfer. Let's go back to TAS Desktop. And if we go here to the IoT templates, now we can see all the templates that I've created here in the TAS Desktop and stored. Here we at the bottom, we find the new one, the UC25 TURCK training, and we can edit exactly what we are transferring. The first thing I do is I select all the data points. And as we can see, we have the menu for the process data and the observation, and I'm turning off the forwarding for all of them. And then we are going through and just going to add the menus or the actual data points that we want to transfer. We can click here on the right side, or you can also select multiple on the left side with the checkbox. Let's make the name somewhat shorter. We can also set the read frequency, and the delta is how big does the difference need to be for us to actually transfer data. So for example, maybe we don't want to transfer the data every 0.1, but if the difference is smaller than 0.1, maybe we want to have a bigger change. That's up to the use case. Again, these at the bottom are the process data, so the cyclical data, but we also can transfer the non-cyclical data. In this case, the supply voltage, and it's just as easy as the process data. So we simply turn on the forwarding, maybe optimize the name a little bit, and then we can also transfer these values. Let's save the whole thing. And then there is always, for each type, sensor type, we can set one as the default. And this is going to be the one that is used during auto assign in the IoT Edge demo or TAS Edge. We can also turn off the default for a sensor type, so then nothing will be assigned automatically. Let's go back to the IoT Edge demo. We changed some of the settings in the IO link sensor, so we can rescan the network to download that information. Now we can select we can select the masters. In this case, we only have one. And then we can choose for the auto assignment, what templates do we want to assign and what names we want to apply. In this case, maybe the Profinet name for the IO link masters. You can also leave it empty or use the IP address. That's up to you. Here we also set the application tag in the sensor, so we can use that, but in other use cases, maybe it's the function tag. We apply, and here we see immediately Profinet name of the master and also the application tag for the sensor, and we also selected the template. If we want to, we can also edit the template from here. Then we store the whole thing, and we can see that it was correctly applied and assigned to the sensor. Now we go to the connection settings, and here we have a lot of options. We can have the target system as TAS Cloud or any MQTT broker. We can set the topic prefix, topic format, depending on the use case and the customer needs. We can have the whole topic as a flat or hierarchical. Again, this depends on the use case for the customer. We can choose the cycle time. So this is how often is the value read from the master. In this case, if we set it to 60 seconds, then every minute the values will be retrieved from the master. Or here, to do it a bit faster, we'll do it every second. We can also choose a data format. So either sending only the value or the value with the unit. We can also use a template. This is again up depending on the use case of the customer. Here you can format the payload. For an MQTT broker, we also need to do all connection settings. So we need to add a username, a password, client ID, add an IP address, and so on. And we can also do some security settings, either here via certificates. This is if you need to connect to an MQTT broker that is secured via TLS. For TAS Cloud, you don't need to do all of that. So what you can do is you download the certificate pack from TAS Cloud, select the target system and upload it TAS Cloud, and then upload the certificate package in here. And it does all the configuration for the TLS, for the certificates, for the IP address, and so on for you. I downloaded the certificate package. Here we have the bundle. We don't need to unzip it. We can just select it, check the connection at the bottom, and we can see connection to the MQTT broker is successful. You can still set a topic prefix for all topics. And here I also removed the IO link menu in the topic. We don't need that. We just want to have a short descriptive name. Apply the whole thing and press start. And now we are sending data to TAS Cloud. In the preview, we can check the values that are being read and that are sent to TAS Cloud. Again, this is being checked. Usually we set it up for once per second. Here the update in the preview is fixed. We can see we have different values coming in, so it's working. So for TAS Cloud, I showed you need to have the certificate pack. How do you get it? You can click on the TAS Cloud button. If I'm not logged in, you will be here. So you can register as a new customer, enter all the information in here that is required, choose your country and so on, enter a name, email address, register as a new company. You will then receive, or the customer will receive, an email. And after confirming the registration, then this customer enters internal validation. After it is validated, then the customer gets an email for activation. The first user in a new customer account is always an admin, so they can log in, and then this admin can invite more users. Again, those users then need to confirm, or will receive emails and need to confirm their account. Let's go over to devices. And here we can see that we have the previous device, and we can also register new gateways in here. We want to send data, so choose the data flat. The SMS service and the VPN bundle are usage-based, so they are always included. However, they are usage-based, so the customer only has additional costs if they use this functionality. Then we confirm everything and we order and reactivate the account. We see that worked. And here we immediately download the certificate. And that is the bundle that we can upload in TAS Edge or in the IoT Edge demo. We are already sending data with the first device, so we can just leave it and let's look at that data in the cloud. So we switch over to the cockpit. We go over to the groups, select the device, and select the Data Explorer, which allows us to look at the data coming in without having to create an exhaustive dashboard. You can see here the name that we chose. Let's add all of them. And here we can see the raw data coming in. Can zoom in a little bit and see the data that we were sending or that we are sending right now. To do a bit more, we can create a dashboard, give the whole thing a name, save it, and add widgets to display the data. For example, let's take the temperature and show it as a big value. So we add the data point, select the device temperature. We can edit the display or customize the display a little bit. And now we see here the temperature coming from the capacitive sensor. We can also add a data point graph where we can see it as a time series. Again, the same thing, add data points, choose the ones we want. In this case, the value, the measurement value, and the switching signal. We can choose the color. It's always difficult finding a good color, especially when you add multiple values. Then we also set the range, so the minimum and the maximum value. And for the switching signal, because we are going between 0 and 1, it's best to choose the step after, because then that reflects the actual signal. So here we can see that we set the switch point at 1600. If we have it as a line, it interpolates, which is incorrect because it's a Boolean value. So we select step after and then it shows it correctly. We can also shorten the label to have it look a bit nicer and then set again for now the measurement value, the actual range we want to see. In this case, from 0 to about 1900. Save the dashboard. Now we want to shorten the time range, only see the last minute. Save it in the dashboard configuration, so when we open the dashboard, it will always show this last minute. Turn on the real-time display. And then hopefully see the value change. Let's make it a bit larger. There we can see the value change, and the value is only updated once a second. So this is a bit of a difference to the monitor, where we can really see it changing really, really quickly. Towards the cloud, the data does have to be limited a little bit. We reloaded the page so that that data point is properly displayed. See the last minute again. That looks a lot better. But with the data in the cloud, we can obviously do a little bit more. So let's add a smart rule. So what we are going to do is create an alarm based on the data in the cloud. So we select the smart rule on measurement explicit threshold, create alarm, which is a very long name. We select the data point. In this case, for example, the measurement value. And then we set the range in which an alarm is created. So let's set it here from 0 to 1500. Give it an alarm type, in this case T3K, material, and then a name. Material detected. We can adjust the range a little bit, depends on the use case again. For example, here we want to ignore oil, which we learned earlier was pretty high. That's why we are only going from 0 to 1000. Then we switch to the alarms. We need to update it relatively frequently. What we can do is we can also add a widget here on the dashboard displaying the alarms, so that we can see the measurement value coming in and also the alarms. So let's add an alarm list. We can filter it. In this case, important that we also include the cleared alarms. Otherwise, they will disappear very quickly. Again, let's look at the last minute. The important part is that this alarm is created based on the measurement values in the cloud. So we are getting only the measurement values that are sent to the cloud once a second. Those can then be used to create further alarms. So for very short occurrences, then you would need to create the alarm actually on the device itself. If we go to an alarm overview, we can also select the alarm in here, and then we can create smart rules or another smart rule based on this alarm type and send an email. So we don't need to always watch the dashboard. We can just send us an alarm based on the alarm, send us an email based on the alarm. We can give it a subject. So for the email, this case, material detected. And also adjust the email text. So from now on, every time this alarm is created, it will also send an email. There is now a very new functionality, which is the new smart rules. And this makes it possible to actually use streaming analytics, which is allows a lot more freedom, a lot more customization for streaming analytics. Here I created one that also creates a custom alarm from the measurement, but it gives me some more customization in comparison to the standard smart rule. So I can choose, for example, the alarm severity, and also here set, for example, a lower threshold or an upper threshold. And I can say, is the alarm if it's inside or outside this range.